In this video, we will discuss two entry-level and mid-level Java interview questions. Number one is how do we use our own custom class as a TreeMap key? And the second question is why the equals method must be consistent with compareTo method. So let's start with the first one. Here we are creating a new TreeMap and the key is of type movie and the value is integer. Then we are adding 4 entries to this TreeMap. If we talk about the movie class, then we see that it has a single property title and a constructor to initialize the title, then a getter, and then the toString method. All right. And after adding the entries to the TreeMap, what we are doing, we are simply printing the map. So if we run this program, we see the exception that equals and compareTo this movie cannot be cast to class comparable. Now we discussed in the last video that TreeMap uses the natural ordering or natural sorting of the keys. And by natural ordering or sorting, we mean that the key or the class that we are using as key must implement the comparable interface. And in this case, because we are not implementing the comparable interface and we are adding the movie object as a key to the TreeMap, so TreeMap has no idea how to compare the movie objects in order to sort them. And the solution we already know. To do that, we simply need to implement the comparable interface. And we implement the method. So I implemented the comparator. It must be comparable interface. And I will simply implement the method compareTo. And we will say that compare the movie objects based on their title, which is string. So use the compareTo method of the string class o.title. Okay. And now if we run this same code again, we see that the entries have been sorted based on their title. So we see John Wick first, then Lord of the Rings starting with L, and then the Mission Impossible starting with M. And because title is string, so the movies have been sorted in the alphabetical order of the string values or the title. That's fine. So in order to use a custom class as a key, we must implement the comparable if we are not providing a comparator. If we are providing a comparator, then we can choose not to implement the comparable interface, but otherwise we have to. Okay. Second thing is, why do we say that the equals method must be consistent with compareTo? In order to understand that, we need to remind ourselves that if we are using a custom class as a key with hash map or linked hash map, then in general, what map does, it uses the equals and hash code method of the entity to find the index in the underlying array and to compare the keys. And that's why we say that we must always override equals and hash code together and correctly if we intend to use that class as a key to the hash map or to the linked hash map. So we know that we must always override hash code and equals together and correctly. Coming to the TreeMap, in the TreeMap, there is no such restriction. What TreeMap does, it uses the compareTo or compare method of comparable and comparator interface. It does not use the equals and hash code. That is the main difference between hash map, linked hash map, and TreeMap. TreeMap does not rely on the equals and hash code. Alright. It requires the comparable interface, in which case it will use the compareTo method, this one. And if we are not providing the comparable interface, but if we are providing a custom comparator, then in that case it will use the compare implementation of the comparator that we passed to compare the keys. Now the problem is, in this example, if we see that we created a movie class and we implemented the comparable method, then we added all those entries to the TreeMap. These two entries are duplicate entries, but TreeMap was able to figure out the duplicacy using the compareTo method. But let's say instead of using the TreeMap somewhere in the same code base somewhere else, we use the same key with the hash map. So we say we create a hash map and we use the same class as the key. Hmap equals to new hash map, and then we add the same entries to the hash map. Okay. All right. Now if we print this hmap, then the expectation would be that there must be 3 entries because these two are duplicate. But if we run this program, then we would see that the tree map has 3 entries. It was able to figure out the duplicate entries, but the hash map is not able to figure out the duplicate entries. There are 4 entries: Lord of the Rings, Mission Impossible, then these two duplicate entries for Mission Impossible, and the last entry for John Wick. That is the problem when for a custom class, equals method is not consistent with compareTo method. Because for the same class, TreeMap is using compareTo or the comparable interface, but the hash map is still trying to do the same thing with equals and hash code, and this class does not override equals and hash code. So this class is breaking the general contract of the map. If the equals method is not consistent with the compareTo method, then this kind of situation can occur in the code base. So while the class was working fine with TreeMap, but the same class is not working fine for the hash map. Now this kind of bug can sneak in if we are not careful with equals and compareTo method implementation. And the second thing is the class is breaking the general contract of map, which says that the keys are comparable based on their equals and hash code method. So if we are going to use this class or any class with the tree map only, then we can choose not to override the equals and hash code. But if that's not the case, then always override the equals and hash code together and correctly, and make sure that the equals is consistent with compareTo. So what that means is, what I will do, I will override the equals and hash code. And because there is a single property, so ultimately if I override the equals method, it will be consistent with compareTo because they both will be comparing the entities based on the same attribute, which is title. So now we are overriding equals and hash code, and equals and compareTo are consistent with each other. This time if we run this program, so we see the correct output, and this time hash map skipped the duplicate entry and it follows the general contract of the map. And the same key would work just fine whether we are using tree map or the hash map or any kind of map. I hope it makes sense. Okay.